Hi everyone. I wanted to go over today's assignment, which was to watch the video of lesson 10.6, go through the notes, but what you were submitting to me were the 3 practice questions from lesson 6. And just from looking at some submissions, I definitely think it would be beneficial to go over this in a video instead of just posting an answer key. So let's take a look at number 1. So I think even if you don't have this information written off to the right hand side, like I have listed here, eventually that won't always be given to you. But this is something you should always be thinking about. And I have to say, overall, this looks pretty good as I'm looking at your submissions, with a couple of things I want to point out. So the amplitude, I think we've all gotten a good handle on that. Let me just turn this so we can really focus in on question 1. Okay. So the amplitude of this curve we can see is 2, since there's a 2 in front of our cosine. Again, amplitude means this curve will go 2 units above the midline and 2 units below the midline. And the midline on this curve, because there's a vertical shift up 1, again, I'm just going to write that in here. That's the middle. So if the middle of my curve is 1, and then I go up 2 and down 2 from 1, that helps me build my range. So again, if we think without that midline shift, we would have gone down 2 and up 2 from 0. Now I'm going to add 1 to both of those values. I'm looking at a range here from -1 to 3. And I have noticed that some people have written the correct range, but then when you actually look at your graph, you should have points being plotted at a maximum of 3 and a minimum of -1 if that's your range. And some of our ranges aren't matching our graph. So we really want to pay attention to that when we get to the point of graphing this function. Okay, so now we've taken care of our amplitude of 2, our midline shift of 1, and how that affects our range. Now let's focus in on what's happening to our x values. So I have a frequency here of 1/2. That's the number in front of x. So if my frequency is 1/2, that would just mean if I looked from 0 to 2 pi, I would only see half of this cosine curve. The domain is not 0 to 2 pi. We'll deal with that later. It's a little bit bigger than that, 0 to 4 pi. Okay, the period is 2 pi divided by the frequency. So in this case, we're dividing by 1/2, which is the same as multiplying by its reciprocal, which would be 2. So you're really doing 2 pi times 2. So we have a period of 4 pi, which means the time it would take for me to see a full cosine curve, which is either max to middle. Here, let me draw this while I'm saying that. Cosine is either going from max, middle, min, middle, max, and the only time it looks a little different than that is if it's also being reflected. It would start at the minimum and end at the minimum. Otherwise, that's a complete cycle, and what we're saying by having a period of 4 pi, this one complete cycle will happen from 4 pi units. So over a distance of 4 pi, I will see this one cycle of cosine. Okay, as far as transformations go, there's no reflection because the number 2, my amplitude, does not have a negative in front. There's no horizontal shift, so all I'm looking at is a shift up of 1 unit, which we've really already taken care of when we wrote out our midline, our amplitude, and our range. But graphically, we'll sketch that in a moment. Okay, now this starting point. I want to focus on this for a moment. So when we talk about a starting point, it's not necessarily always in our domain, but I'm referring to this. I'm referring to the fact that typically cosine starts at its max. Okay, so this curve actually will start at its max because there's a positive in front, so there's no reflection. So if this curve is going to start at its max, I have to think about, well, what is its max? The maximum is 3, right? And because there's no horizontal shift, that means I'm still on the y-axis. So this curve is going to have a starting point up here of 0, 3. And we're going to focus on the starting point in the other graphs too. I think it will be helpful. Okay, now my critical value interval. Let's get back to our axes. So I'm going to take my period, which in this case is 4 pi, and I'm going to divide it by 4. So this is a nice critical value interval because it's a whole unit of pi. So if my domain is 0 to 4 pi, I think we said. Let me just double check. I think, yes, 0 to 4 pi. So I want to be able to label my x-axis in units of pi. So 1 pi, 2 pi, starting at 0, 3 pi, up to 4 pi. So these are the values that I'm going to label my x-axis with. I also want to make one other comment. You have to make sure this is an interval, right? A critical value interval, but this means that every tick mark that you put on your x-axis is going over by pi units. So it has to be the same amount of boxes that you're counting. I am seeing a lot of graphs where the critical value interval, you might have the right numbers on your x-axis, but they're not necessarily correct because you're skipping by a different amount of boxes each time. So we just have to be consistent when we pick an interval. Just like on the y-axis, if I'm going to go up to 3, I might decide to make every box 1 unit or every 2 boxes is 1 unit, but I have to be consistent. Okay, so since we are only plotting positive x values and we don't have any kind of horizontal shift where I have to think about going left of that, I'm going to put my y-axis all the way to the left. Again, you don't have to do that, but we're not plotting anything to the left of it, so I'm just going to leave it over on the left. And we are going above and below the x-axis, so I'm going to put the x-axis semi in the middle. Okay. So now I'm ready to start at least putting some tick marks on my axes. So for my range, I'm going up to 3. So I typically like to give myself a good visual by having some room on my graph. So I'm going to go up for every 2 boxes. I'm making that 1 unit. And notice how I was consistent. 2 boxes to 1, 2 boxes to 2, 2 boxes to 3. Same thing going down. I have to go to -1. So 2 boxes to go down a unit. Now my midline is y equals 1. So I'm also, while I'm doing this and getting myself set up, I'm going to draw that in so that I know where my middle is. Because a lot of us, even with the midline, we are still plotting points on the x-axis. You only are plotting for these graphs points at their maximums, minimums, and midline. So if the midline isn't on the x-axis, you actually won't have any points plotted on the x-axis. Your graph will cross it possibly if there's negative values in your range, but it won't have points plotted on it. Okay, and then let's look at the x-axis. So I have to put pi to 4 pi. So here's 0. I'm going to skip 4 boxes. 1, 2, 3, 4 boxes is pi, which means these 4 boxes is also another pi, but because I've gone 2 pi, I'm labeling it as such. And then 1, 2, 3, 4, another pi would get me to 3 pi, and then another pi gets me to 4 pi. So you definitely want to make sure that that interval is consistent. I don't care how many boxes you skip by, as long as you can stay consistent with your interval. Okay. So now we're ready to graph. So again, let's remember what this cosine curve is doing. It's starting at its maximum. It's going to go to the middle, to the min, back to the middle, and end at its max. Just trying to highlight that for you guys. I don't think that worked. So here, max and around. I'm trying to highlight this graph up here in red. I don't know why it's not really showing up. Okay. So let's recreate that on this curve. So we have a maximum starting point at the point 0, 3. Then cosine from there goes to the middle. So we're going to plot our next critical value, which is pi. We're going to plot that point at the middle. Then cosine goes to the minimum at the next tick mark or the next critical value. So at 2 pi, I'm going to go to the minimum, which is -1, right? We'll look back at my range. My min is down at -1. My max was up at 3. Okay, then cosine goes back to the middle. So at 3 pi, I'm going back to the middle. Again, a nice reason why you want to sketch in your midline, because now I can see visually where my middle is. And then 4 pi, next critical value, we're going to go back to the max, and that's up at 3. So let me plot that point at 4 pi, 4 pi comma 3. All right, and now we're ready to sketch a smooth curve, as best as you can. It should not have edges. It should be as smooth and wave-like as possible. Okay, let's take a look at the next graph. Now this graph was a little bit more difficult because of the fact that it has a horizontal shift going left, but the domain, we're only being asked to graph positive values. So we're going to deal with that again at the end when we get to the graph. We're still going to spend the majority of our time listing what's important. So let's start right off with amplitude. Now you can see on this curve, yes, there's a negative in front. We'll deal with that when we talk about the transformations, but this does have an amplitude of 2 for this cosine curve. The range, okay, well, let's think about the midline. There is a midline of 1. So we're going to really have the same range as our last graph, right? Yes, we had an amplitude of 2 and a midline of 1 for a cosine curve. So we're going to have the same range. Instead of -2 to 2, we're shifting up 1. So we're going to be -1 to 3. Okay, now we're ready to look at frequency. Well, this curve has a horizontal shift, but we have to remember your frequency is always going to be factored out if there's a horizontal shift. So the only thing here that's possibly multiplying this angle of x is a factor of 1. So my frequency is 1, which makes my period 2 pi divided by that, so it's just 2 pi. Okay, as far as transformations go, we have a couple of things happening here. So first, we have a reflection over the x-axis because there's the negative in front of my amplitude of 2. We have this midline shift up 1. And we have this horizontal shift, which really means we're going to go to the left pi over 2. So let's just think about for a second what that's going to look like. So when I usually sketch these curves for you guys, I sketch them really just the parent function. So we're basically saying, let's take this parent function of cosine, which starts at the max, goes to the middle, to the min, back to the middle, to the max. Let's take this shape and do these 3 transformations. So if we reflect over the x-axis, let's just talk about that one. That's where this shape would come from. So instead of starting at the max, it starts at the middle. The minimum. Then from the minimum, it goes to the middle, to the max, to the middle, to the min. So that's just the reflection. But then let's say I want to take that up a unit. Okay, so now I'm going up a unit. So now I'm here to the middle, to the max, to the middle, to the min. Okay, so that was my up. But now if I had to go left with this, just bear with me for 1 second. I just want us to get the good visual here. Now I have to take this curve, what color can I use? Orange. And I have to go left pi over 2. So if this is my parent function that I'm sketching over here, the parent function has a period of 2 pi, which means its critical value interval, which let me put down here, would be 2 pi over 4, which is pi over 2, which means all of these things that I was doing, these tick marks, if I put them in here, they were all going over by pi over 2. So now if I go left pi over 2, this would technically, again, I'm taking the purple graph here. That's the one that I've reflected and shifted up 1. And now I'm bringing it to the left. So I'm going from the minimum to the middle to the maximum, back to the middle, back to the min. So if I just took that curve, I reflected it in green, I shifted it up 1 in purple, and then I went left pi over 2 in orange, this curve is now what I'm looking at, but I'm also going to only graph from 0 to 2 pi, so I'm not even going to see that whole orange curve. So if that hopefully just gave you a good understanding of what we're going to do, what we want, obviously, you're not necessarily ever going to have to do something like that. Sit here and try to, sketch what's happening. But if you can think about what's happening, it helps you know what to do with your axes, and ultimately where we're going to plot our first point. So I'm getting a little ahead of myself. So let me come back here to my critical values. So before we start putting our axes together, our critical values are pi over 2. That's the interval. We're going from 0 to 2 pi. So I'm going to start at 0, then go 1 pi over 2, 2 pi over 2, which is really pi, 3 pi over 2, and then 4 pi over 2, which is really 2 pi. So if I simplify, these are just my quadrantal angles in radian form. So this is my pi over 2 is 90, 180, 270, 2 pi is 360. And even though those are the only values I want to see, since we're moving left, we technically want to think about this point, this starting point that was all the way over here on my little sketch above. So even though I don't need to show negative values in my domain, I'm not going to put my y-axis all the way to the left because I do want to think about the fact that this curve doesn't start on the y-axis, or even better yet, only think about it going positive. I need to think about some negative x values because of the left shift. Okay, so if I plot these values, let's see, can I go over 4? 1, 2, 3, 4 on my x-axis. That would be pi over 2. 1, 2, 3, 4. This would be pi. 1, 2, 3, 4. 3 pi over 2. 1, 2, 3, 4. 2 pi. And then I'm just going to put over here 1, 2, 3, 4 negative pi over 2 so we can visualize this horizontal shift left pi over 2. Now our range, I'm going to go up to 3. Again, I'm skipping 2 boxes and down to -1 since that is my minimum. And I'm going to put in my midline at 1. And now because I have this horizontal shift in addition to this vertical shift, I'm going to add a vertical line for the horizontal shift. So since we're going left pi over 2, I'm going to sketch in this line. And you know what, to help me out here, let's do this. So we before used orange for the left shift, so I'm going to highlight this in orange. And then I had used purple for the up, so I'm going to do purple here. Because these lines are meant to act as my axes, even though they're not my x and y axis. I'm going to kind of use them the way I used my x and y axis when these graphs were not being shifted. So if I think about the fact that I'm graphing a cosine curve, cosine typically starts at its max, but because there's a reflection, it's going to start at its min. Not only do I have to think about, okay, the minimum of this curve is 3, is -1, where my head just went for a minute. So the minimum is -1. I'm also going left pi over 2. So I need to go negative pi over 2, comma -1 as my quote unquote starting point. So I'm going to plot a point here. So there is my minimum, shifted left, at -1 since that's my min, at negative pi over 2 since that's my horizontal shift. And then let's think about where cosine would go. So if this is cosine's minimum, it's going to then, at the next critical point, which is 0, it's going to go to the middle. So here's my middle. Then at pi over 2, which is the next critical value, it's going to go to its max. So my max is 3. At pi, it's going to come back to the middle. At 3 pi over 2, it's going to come down to the min. And then because my domain is all the way to 2 pi, I have to keep going. I'm going to go back to the middle. Now, this point over here, I'm just going to draw an arrow in. This point is technically not in my domain, so I'm not actually going to sketch that in my curve. I'm going to start at 0, 1, because that's the first point in my domain, and I'm going to sketch what I have here. And then that stray point, I used it to help myself. I could go back if I want, like if this was a test, I could kind of cross it out, or if I, had whiteout or eraser, if I was using pencil, I could just erase it. But ultimately, even though it's not in my domain, it was critical for me to think about this point so that I knew where this cosine curve technically would have started. I hope that makes this one a little bit more clear. Okay, let's try one more. So now we're looking at a sine curve. Sine curve that, again, has a reflection, a horizontal, and a vertical shift. So we have all three things happening here. The amplitude is 1. The midline shift for this curve is 2. So y equals 2 is the middle. So typically an amplitude of 1 would bring me down 1, up 1 from the x-axis, but we're moving up 2. So my range is really going from +1 to 3. So we don't have any negative y values on this curve. So that could kind of, tell me where I might put my x-axis, but we'll get there in a moment. Now my frequency again is 1. There's no value in front of my angle of x other than a 1. The period then is 2 pi over 1, which is 2 pi. Okay, I have three things happening. We said there's a reflection over the x-axis, which really for sine means it still starts at the middle. That never changes for sine. It always starts at the middle or the midline. And then typically sine goes up. So sine, because of the reflection, would go from the middle to the min. And then goes to min. Okay. And then I'll put these over here. So then we're also going up 2 and right pi. All right, so we'll come back to the starting point. Let's do the critical value interval. So if my period is 2 pi, we divide that by 4. So this is again pi over 2. So we're really dealing with the same interval as the last example and the one before that, except for the fact, actually no, the one before that was 1/2 frequency. So it's the same interval as number 2, but my domain is different. I'm seeing some negative and positive values of pi. So if I'm starting at negative pi and I have to get to positive pi, I don't really want to add and subtract pi over 2 from pi or negative pi. So I'm going to think about, well, what's in the middle of positive and negative numbers? 0. So if I start with 0 and I add pi over 2, and then if I was going to add, let's say, another pi over 2, I would be at 2 pi over 2, which really is just pi. So I'm done in that direction. And then the same thing in this direction. If I subtract pi over 2 from 0, I get negative pi over 2. And then again, if I did that again, negative pi over 2 and another negative pi over 2, I would get negative 2 pi over 2, which is just negative pi. So these are the values I'm going to put along my x-axis. Okay, now starting point. So we said typically for sine, I'll draw this one down here. Typically for sine, it starts at the middle, it goes to its max, middle, min, middle. This is the parent function of sine. No transformations at all, going up 1 and down 1. So this sine curve is not only being reflected, which would mean it's going from the middle, then down, middle, up, middle. So if it was just being reflected, this would be the sine reflection in green. But we're also going up 2 and right pi. So let's see, if I went up 2, now I'm way up here. This is hard to do without a scale, and I'm realizing this might be a little bit more effort than it's worth, but let's just stick with me for this example and then we'll start graphing. So we shifted up 2 units. So now we're going, we're above our original parent function because they only go up and down 1 unit. But now we have to take this curve and go to the right pi. So typically, again, if this was a parent function of sine, this would be 2 pi over here, which means pi would be in the middle. So we're saying we're going to take this curve and we're going to start here. And then we're going to not only reflect, but we're also going to start in the middle. So we're going to go down, back up to the middle, max, middle. Okay, so I think that is not something I would focus on. I'm just trying to give you guys a visual. Let's actually go on to our grid and then we will take it from there. So we need to show positive and negative x values since that's the domain. And we also talked before about the fact that our range is all positive. So technically we don't need to show our x-axis in the middle. So I'm going to put my y-axis in the middle since we're going an equal distance right and left of it, pi and negative pi. But my x-axis, I mean, you don't have to put it all the way at the bottom. You technically could. I'm just going to put it closer to the bottom since I don't really need to go below it. Okay. So now what we're going to do is put in our midline shift and our horizontal shift. So the midline is 2. My range is going from 1 to 3. So I'm going to make those range values. And the midline is 2. So let's sketch in the midline. And then we said for our x-axis, we're using these values down here, negative pi over 2, 0, and then positive pi over 2 and positive pi. So let's go maybe 4 boxes, pi over 2, another 4 boxes, pi, this way, negative pi over 2, and then negative pi. Now this graph has a horizontal shift to the right pi, so I'm going to put a vertical line at positive pi so that I know where my horizontal shift is. I'm going to highlight these. Just highlight them with the same color in this example. So honestly, I think this visual was more confusing than I meant it to be, guys. So sorry about that. Okay. But I wanted us to think about those 3 things. So we have a sine curve that is going to always start at the middle, but because it's being reflected, if you think about the curve from where it starts going to the right, reading the graph from left to right, sine would go down. So let's think about where this curve's starting point is. So the middle of this curve is 2 as far as the y value. So the starting point is definitely going to be at 2 for y. And typically, it's on the y-axis. So it would have had, let's say, maybe a y-intercept of 0, 2. But now we're shifting to the right by pi. So here is my starting point, pi comma 2. So this point right here that I'm plotting is almost acting as my origin. It's not the origin, but if I think of these shifted lines as my new axes, technically that would be what that point would look like. Okay, so pi comma 2 is where this curve would start. And now I want to think about the fact that I'm actually at the end of my domain. I'm at pi, so I really don't have to graph anything to the right of this. But what I want you to think about is that this curve, if I went to the right, it would go down. So now I have to graph actually backwards here. I have to go to the left because I have to graph this curve all the way to negative pi. So if it would go down, let's say on the right side, I'm just going to put an arrow for the visual. That means on the left side of this middle point, it's going to go up. So at pi over 2, which is the critical value right before pi, I'm going to be up at my max. Then at my next critical value of 0, I'm going to come back to the middle. Right? If you were just at a maximum, that means you would come back to the middle. And if you're at the middle, having just come from a maximum point, that means you would go to a minimum point at the next critical value. And then if you're at the minimum point, the only way to go from there for any of these curves would be back to the middle. So I'm going to sketch just what's in my domain. And then I can get rid of this little arrow. It was mostly just meant to help me think about what would have happened if I was able to go beyond pi outside of this domain. Okay, I hope these videos helped clear up some of the graphing. I do understand, guys, that this is a lot to be learning in a video, and it's hard when you're not, in class and able to ask me questions. But please use Canvas. I'm really trying to get back to those of you that are sending me emails or Canvas messages as promptly as I can. I did put up a discussion board yesterday. No one really used it, but I will post another one because I do think it would be helpful once we kind of find our groove here, that if people wanted to post on the discussion board, I can respond. Other people can start chiming in and responding if you feel like you can help a student out. I think that would be great. So I hope this video was helpful. Please go back now and, check over your graphs, make corrections on them. And all we're going to do tomorrow is practice more of this graphing. Okay, so if you still feel like you need more time with it, we have a lot of time. Okay, so just keep practicing. All right.